Hello. In our last lecture, we had discussed the velocity transformation formulas. We eventually started from Lorentz transformation, putting the transformation into a differential form, then eventually evolved and worked out the velocity transformation. Then we also discussed an example of relative velocity to emphasize what we mean by relative velocity. In classical mechanics, sometimes we are a bit casual in defining relative velocity, but in relativity one has to be very careful that when we say a relative velocity, it means we have to make a transformation to another frame and find out the velocity of the particle. And this relative velocity would never exceed the speed of light. Then we also discussed a particular example in which there are three different frames of references were involved. We have been earlier doing generally two frames of references. So, to make problem little more difficult, we had involved three different frames of references and saw that how one has to take care of looking into transformations from one particular frame to another particular frame of reference. But so long we do things in a proper way, we should not have any difficulty. So, this is what I have written, that let me recapitulate. We worked out the velocity transformation. We discussed examples of relative velocity and those involving transformations between three frames of references. This is what is the velocity transformation equation. Just to recall, again I mentioned that V is the relative velocity between the frames of references. Ux is the velocity of a particular particle, which need not be constant. It is the x component of the velocity of the particle. We are supposed to know Ux, Uy is the y component of the velocity of the particle as measured in S frame, and Uz is the z component of the velocity as measured in S frame. Then the velocity of the same particle measured in S prime frame of reference, the components will be given by, the x component will be given by this equation, the y component will be given by this equation, the z component will be given by this equation. What is interesting here is that if we look at Uy prime, it also depends not only on Uy, but also depends on Ux. Similarly, Uz prime depends only on Uz, but also depends on Ux. So, this particular factor Ua, which is involving Ux, is appearing in all the three transformation equations of all the three coordinates, all the three components of velocity, Ux, Uy, Uz, or Ux prime, Uy prime, Uz prime. We also discussed inverse velocity transformation. It means if the velocity components are given in S prime frame of reference, how to find out the velocity components in S frame of reference. As we have always been telling, the prescription is very simple, that instead of V, use minus V, change prime quantities to unprimed quantities and unprimed quantities to prime quantities. So, this is what basically we had discussed in our last lecture. In today's lecture, we will discuss one example which is little more complex, little more complicated, involving multiple events and multiple frames of references. The idea of discussing this particular example is to see what type of care we must do, or what is the way in which we should attack these problems when there are multiple events and multiple frames. As I have been telling, that first thing that one has to look is that be consistent in your frame of reference. We should not mix up the frames of reference, which many times in classical mechanics we are not very careful. So, we should picturize the scene looking purely from the point of view of one frame of reference. Then the chances are less that we will make mistake. The second thing that we do is to identify the events. What are the important events? Try to write the coordinates of those events, including time. Time also we are treating as a coordinate. And these coordinates, once we have written in a particular frame of reference, let us try to find out whether we have got all the coordinates. If we have not got the coordinates, whether we have got an equivalent information in some other frame of reference, then we keep on making transformation and eventually we fill what we call as an event table. It means all the events should be known in all the frames of references their coordinates should be known in all the frames of references. So, once we have defined these events, the coordinates of these events must be known in all the frames of references that are of interest to us. So, let us look at this particular example. The example statement is a little longer. Let us go slowly and try to understand it. A person gets sick while moving in a train. Of course, because we are dealing with special theory of relativity, everything moves with a constant velocity here. There is nothing like, and nobody stops, everyone is moving with constant velocity, because that's the way we solve the problem. Because once if a person stops or anything happens like that, then it's no longer in purview of special theory of relativity, because it does not involve a inertial frame. So, all our velocities are constant and they never change as far as the examples are concerned. So, there is a person who has got sick while he's sitting in a train, and of course, train is moving with a constant velocity and it's a relativistic velocity, and this speed is 0.6 c in plus x direction as seen by an observer in a given frame. Let us assume that this is a ground frame or earth frame, which we also assume to be inertial. Now, this person who gets sick, I am calling this particular person as P frame, just to be making little more clearer, so that when we talk of S prime, S double prime, things tend to become a little more involved. So, let us put in a specific symbols. So, because we are talking of person, so I am calling this as a P frame. Now, this person, once he gets sick, he sends a distress signal by emitting light. So, he emits light asking for help, and at that particular instant of time when he gets sick and he sends the signal, he is 30 kilometers away from the origin in the plus x direction. That is what we have written. A person gets sick while moving in a train, the speed of which is 0.6 c, which is obviously relative to the ground, in the positive x direction. Call this frame P. He shines light asking for help when he is 30 kilometers away from the origin in plus x direction. Now, there is a hospital which is located at the origin, which let us assume is again the ground frame, and we call this particular frame of reference as H frame, because this is the hospital frame, which is actually same as earth frame if you want to call it. So, a hospital is located at the origin, and as soon as this particular person receives the light signal, he tries to look for an ambulance, and he finds by that time, fortunately, that there is just an ambulance which is just passing by him and going in the direction of the sick person, but with a little larger speed, 0.8 c. So, he instructs the person that, or he instructs the ambulance that you go and help the person. So, that is what is the problem. A hospital is located at the origin called the H frame. As soon as the light reaches the hospital, an ambulance called A frame, a person sitting in ambulance, I am calling that as an A frame. So, there are three frames. Okay, there is a P frame, which is a person's frame who sends a signal. There is H frame, which is hospital frame, which I am calling as the earth frame. And there is an ambulance frame, a person sitting in the ambulance, which I am calling as A frame. So, an ambulance called A frame is found in front, which is moving in plus x direction with a speed of 0.8 c. The earlier speed of the person was 0.6 c. Now, the person in the hospital instructs the ambulance to go and help the sick man. He says, go and help that person. Assume no time delay between receiving the signal and giving the instruction, and no slowing down of car and train. So, let us assume that as soon as the signal is received instantaneously without any time delay, he could instruct the driver of the ambulance that go and help the person, and the ambulance person immediately rushes towards the sick person. Anyway, he was anyway going, and there is no slowing down anywhere. So, whatever are the speeds, they are always constant, because that is what is necessary to maintain that all the frames of reference that I am talking are inertial frames of reference. So, no slowing down and no time delay in conveying the information from the hospital frame of reference to the driver or the ambulance frame of reference. Now, these are various questions which have been asked. Question number 1, what are the positions and times of the person sending the signal in H and A frame, that is the hospital and the ambulance frame of reference? What is the position? Some of them will be simple questions, some of them will be little more difficult questions. Let us see. The second question which has been asked, find the position of the person in H frame, which is hospital frame, at t is equal to 0, and in A frame, which is the ambulance frame, at t prime equal to 0. Number 3, find the time in H frame and A frame when the ambulance reaches the person. So, eventually the ambulance reaches the person, and we have to find out what is the time in H frame and A frame. This is basically the problem that we are going to work it out. So, I have sort of picturized this particular thing in this particular transparency. So, this particular person, this is sort of a generic figure. So, just to sort of understand, we will draw a specific figures relevant to a particular frame of reference little later. So, this is a hospital which is supposed to be situated on ground, and this we call as H frame. This is my car which is moving with a relativistic speed of 0.6 c going towards the right, which I am calling as P frame, because this person is sitting in this particular train and that is where he gets sick. Let me call this is my ambulance, which I am calling as A frame, which is also moving to the right with a speed of 0.8 c. Of course, this information of 0.8 c, this speed of 0.6 c, both are given in H frame, which is the ground frame. That is the way we have described this particular problem. Now, we have to answer various questions as we have discussed just now. So, this is just a picture to give an idea, and the distance was 30 kilometers at the time when the light signal was sent from this particular person towards H, which we call as a distress signal, just to give the information that there is something wrong with me, please come and help me. As I said, our first job in all these problems is to identify events. See, which are the events which are important in this particular case, and then eventually start looking and filling the event table by putting the coordinates of all these events. So, if you look at the statement of the problem and think a little bit, you will realize that there are 3 events which are important in these events. In this particular problem, there are 3 events which are important in this particular problem. First, which I call as event number 1, is the sick person sending the distress signal. So, person is sick, so first thing that he does is to send the distress signal, he sends the signal. That is the event number 1. Then the signal is received by the hospital, that is event number 2. So, hospital receiving the signal is event number 2. Of course, as we have said, that is the same time he instructs the ambulance. So, instructing the ambulance, etc., everything occurs exactly at the same time. So, they are all included in that event number 2. So, event number 2, you also find that the ambulance is just in front of hospital, that is also an event number 2. So, event number 2 comprises of various things in that sense. Now, event number 3 is that actually the person who is sick, he is actually able to, the ambulance is able to reach that particular person. So, that is my event number 3, that is ambulance reaching the sick person. So, these are the 3 important events as far as this particular problem is concerned. Sick person sending the distress signal, event number 1, hospital receiving the signal, event number 2, then ambulance reaching the sick person, this is event number 3. Now, let us choose one particular frame of reference and try to write the coordinates of all these 3 events in that particular frame of reference. If you realize that in this particular problem, in fact, all the information has been given in H frame, that is the hospital frame or the ground frame. So, it is much easier to write the events in this particular frame itself. So, what I will do to make it systematic, it is much better to go systematically while solving relativity problems. What we will do is to write the coordinates of these 3 events in H frame, the hospital frame, that is the ground frame. So, that is the way first we will do, then we will look into other frames and then we will go ahead with the particular problem. So, let us first try to write the coordinate of event number 1 in H frame, the hospital frame. It has been given in this particular problem that the light signal was sent by the person when he was at a distance of 30 kilometers. So, obviously, and of course, we have said that hospital is situated at the origin. So, the coordinate of this particular event, the x coordinate of this particular event is obviously 30 kilometers. That is very, very clear. We should also look at about the time aspect, because as far as the question is concerned, though there is nothing specifically has been mentioned about in the problem about time, but we have to choose an origin for time. And looking at the Lorentz transformation, we have to choose the time when the origins coincide, as we have always said. So, it is quite simple to realize that most of the problem is given between H and A frame, the hospital and the ambulance frame, and it so happens that when the light signal is received in H frame, that is also the time when the ambulance is passing by its side. So, let us call that time as t is equal to 0 in H frame, and that will also automatically turn out to be t prime equal to 0 in A frame, that is the ambulance frame. So, time is chosen at that particular instant. But we realize that though the hospital received the signal at time t is equal to 0, the event must have occurred before, because light took finite time to reach this particular person. See, as we have said in our earlier lecture, that it is not important when I get the information, what is of importance at what time the signal, or what time the event took place. For example, if somebody is departing from railway station or one particular or by a flight, and somebody comes and tells me that, okay, no, some of your relatives is going away and somebody has gone to see him off, then he comes back, he says, oh, flight was in time, no, it really departed at 9 o'clock. It does not mean that you got the information. Obviously you did not get the information at 9 o'clock, you might have got up at 10 o'clock or 9:30. But it does not mean that the event occurred at 9:30 or event occurred at 10 o'clock. You know that event occurred actually at 9 o'clock. So, similarly, once I have received the light signal, in my watch time t is equal to 0, but I also realize that this light would have taken finite amount of time to come from 30 kilometers. So, this event must have occurred earlier. So, when I have to find out the time of this particular event, I have to take this particular factor also into consideration. So, this is what I have written in this particular transparency, that in H frame, event number 1 occurred at coordinate, because the event number 1, so I am calling it this as 1 at 30 kilometers, which in SI system turns out to be 3 into 10 to the power 4 meters. So, the x coordinate of the event number 1 is 3 into 10 to the power 4 meters. The time for this particular event has to be found out by finding out how much time light took to travel to the hospital. And as I know the distance is 30 kilometers, the light must have taken 30 kilometers divided by its speed, that much time to reach there. And obviously, this event would have occurred in negative time, because time was 0 when the light signal was received at the hospital. So, therefore, this time t1 will be equal to 3 into 10 to the power 4, which is the distance at which the event occurred, divided by the speed of light. And if you calculate this number, assuming c is equal to 3 into 10 to the power 8 meters per second, you get this time t1 as -1 into 10 to the power -4 second. It means this event must have occurred at time 1 into 10 to the power -4 second before the light reached. So, this is a point which has to be realized, that what we have to look is at the time when the event actually took place, and that time is a negative time, even though the person at the hospital received the signal at time t is equal to 0. So, I have found out what is t1. Now, let us look at E2, the second event, for which to find out the x coordinate and time coordinate is very simple, because when he received the signal, obviously he was at its origin, he was in the hospital. The person whosoever was the person who received the signal at the hospital, he was obviously sitting in the hospital and therefore was at the origin. And we have already said that when he received the signal, time was equal to 0. So, the coordinate, x coordinate of the second event is 0, and the time coordinate of the second event is also 0. It is the most simple. That is what I have written here. E2 is equal to x2 is equal to 0. This second event, so I have put 2 here. Second event, so I have put 2 here. So, x2 is equal to 0, t2 is equal to 0 is the coordinate for the event number 2. Of course, we have said, given that the hospital is the origin, which has already been given in the problem. Now, let us come to event number 3. This is a little more tricky, but remember, everything has been given in the H frame. So, it is not that all that tricky. In fact, you do not require Lorentz transformation here. So, I still do not know at what value of x the person actually caught, the ambulance actually caught the sick person, or ambulance met the sick person. Also, we do not know the time, we have to work it out. I realize that during the time light was approaching the hospital, this person must be moving to the right. Let me just draw a figure to explain this particular thing. So, if we say that this is my hospital, and at t is equal to 0, this is where was my train. This distance was 30 kilometers, but light took certain amount of time to reach from here to here. During this particular time, this particular train compartment would have gone ahead. So, at time t is equal to 0, this particular train would be somewhere on the right hand side. So, this is the situation when this particular person sends the light signal. It took certain amount of time for light to reach here. During this particular time, this particular train compartment moved to the right and reached somewhere here. Then there was an ambulance which went and tried to catch this particular person. By the time this particular person in the ambulance goes and catch this person in the train, okay, this event obviously would have occurred at a farther off value of x, because this person continuously keeps on moving with a speed of 0.6 c. So, let us first find out the position, this particular position at time t is equal to 0, where the person was situated at time t is equal to 0. Remember, this distance was 30 kilometers. So, if distance was 30 kilometers, all I have to find out that during the time light traveled from here to here, how much this person went from this side to this side. I have already known the time that light took to reach here. This train is moving with a speed of 0.6 c in this particular direction. So, 0.6 c multiplied by the time will be this distance. That is what I have calculated, added this to 30 to get the distance at t is equal to 0. So, that is what I have written. The position of the person at t is equal to 0 is this original 30 kilometers plus the time that light took to reach the hospital multiplied by the speed of the person, which is 0.6 c. If you just add these numbers, it turns out to be 4.8 into 10 power 4 meters. It means at that instant of time when the light reached the hospital, this particular person was at a distance of 48 kilometers. His coordinate was 48 kilometers. Okay. But remember, this is still not x3, because x3 event involves the catching the person. It will take still further more time before the ambulance will be able to reach, because this is the time when ambulance was still at the origin of H. So, it will still take further certain amount of time for the ambulance to reach this person. Therefore, obviously, what I have calculated here as 48 kilometers is not x3. I have to still find out x3. So, this is the picture which I had drawn on the paper. Same thing has been drawn here. At time t is equal to t1, he was at a distance of 30 kilometers. At time t is equal to 0, it had gone 18 kilometers further off. So, this distance was 18 kilometers. And at really time t is equal to t3, when this ambulance will come here and catch him, the distance has to be further off. So, I have to find out this time t3 and I have to find out this value of the coordinate, not this value of the coordinate. So, this is I have just found as an intermediary step, but eventually the event is this particular person being caught by the ambulance, and that will occur at a different value of x. So, let us try to find out that particular value of x. Let us assume that t3 is the time when ambulance reaches the sick person. Of course, this time is also in H frame. Remember, at this particular moment, everything is being talked in H frame, no other frame. I am not confusing with any. I have written in the first transparency H frame, and all those things are being talked only in H frame. I am not looking at any other frame. I am not even thinking about any other frame, the A frame or the P frame. I am only thinking about H frame, trying to do all calculations in H frame. Once I try to describe into different frame, then I will think only in that particular frame. I will not think in terms of H frame. This is something which is very, very important, not to confuse between the frames when we are trying to work out the problems of special theory of relativity. So, let us assume that time in the watch of the person sitting at the hospital was T3. When the third event took place, it means when ambulance reached the sick person. Now, already we had agreed that this distance was 48 kilometers. And at this particular time, the watch of this particular person showed time t equal to 0. And if time t is equal to T3, it means during this particular T3 time, this person was also going in front with a speed of 0.6 c, while this particular ambulance, which is here, was traveling to the right with a speed of 0.8 c, and in the same time T3, the distance covered by this particular person sitting in the ambulance will be this to this, and the same distance in the same time this particular ambulance will travel a distance from here to here. Original distance was 48 kilometers. So, 48 kilometers plus in T3 time whatever distance this particular train travels, that will be this distance, and that distance must be same as the distance travelled by this particular car in time T3. Of course, this car travels with a speed of 0.8 c. Hence, this distance travelled by car in time T3, this distance travelled by the train in time T3 plus original distance 48 kilometers must be equal, and therefore, I can evaluate T3. This is what I have written in this particular transparency. If T3 is the time taken when the ambulance reaches the sick person, then the original distance 48 kilometers plus the distance moved by the train in time T3 will be 0.6 c multiplied by T3, because the speed is 0.6 c, must be equal to, because as far as the ambulance is concerned, it also travels with the same time T3, but with now a speed of 0.8 c, must be equal to 0.8 c multiplied by T3. So, from this you can calculate the time T3. If you take this to the right hand side, 0.8 c minus 0.6 c becomes 0.2 c, so which comes here in denominator, and then I calculate time T3, which turns out to be equal to 8 into 10 to the power minus 4 seconds. So, this is the time for the event number 3, because this is the time when the person is actually caught by the ambulance. So, T3, that is why I have written this as T3. This is the time for third event, which is taking place at time 8 into 10 to the power minus 4 seconds. Now, if I have to find out the x coordinate, if I have to find out this particular distance from the origin, this will be just T3 multiplied by this speed, or 48 plus 0.6 c multiplied by T3. So, any of the method will give me the coordinate x3. That is what I have done in the next transparency. The coordinate of the person at the time of event 3, that is the ambulance catching this particular person, sick person, occurred at a time 0.8 c is this speed of the ambulance, multiplied by the time which we have just now calculated, which was here 8 into 10 to the power minus 4 seconds. This is what I have calculated. If I multiply this by this, I find out the distance at which this event, or the coordinate at which this particular event would have occurred, which is 19.2 into 10 to the power 4 meters, which happens at 192 kilometers. It is quite far off. So, at the distance of 192 kilometers, or at the coordinate of x3 is equal to 19.2 into 10 to the power 4 meters, event number 3 occurred. Now, I have filled this particular event table in H frame, the hospital frame. So, which I have written here in my next transparency. This is events table in H frame of reference. Event number 1 occurring at a distance of 30 kilometers and at a time of minus 1 into 10 to the power minus 4 second, E2 simple 0 0, E3 occurs at a distance of 19.2, or at a coordinate, it is better to say coordinate. It occurs at a coordinate of 19.2 into 10 to the power 4 meters, and at a time of 8 into 10 to the power minus 4 seconds. So, I have filled the event table in H frame of reference. Once I have got all these information in one frame of reference, then it is a very simple job to transform these information to any other frame. All you have to do is to use Lorentz transformation. So, now let us try to fill this particular table in A frame, the ambulance frame, because H and A obviously satisfy all the conditions or all the criterion which we have imposed for using the Lorentz transformation. Just simply use Lorentz transformation and I get all these events into A frame. So, that is what I have been doing here. I go to A frame. So, now stop thinking about H frame, start thinking in terms of ambulance frame. Make the frame H and A satisfy the criteria to use Lorentz transformation directly, which essentially means that I have to put T prime equal to 0 exactly at the same time when the origins were coincident, and also I assume that that was the origin of the ambulance. Because I have to transform from these two frames, so I have to use the relative velocity between these frames, which is a relative velocity between the hospital and the ambulance frame, because the velocity has already been given in the H frame. So, same is the relative velocity, because that is how we have defined relative velocity. So, V is 0.8 c. Substitute in this expression for gamma, c square will cancel with this c square, this gamma turns out to be equal to 5 by 3. So, the gamma that I am going to use in this particular equation will be 5 by 3 and V will be equal to 0.8 c, because I am going from H frame to A frame and the relative speed between these two frames is 0.8 c. E1, the first event, it occurred at a distance of 30 kilometers. So, this is x minus Vt, because t is negative, minus 1 into 10 to the power minus 4. So, this becomes plus. So, 3 into 10 to the power 4 plus 0.8 c into 10 to the power minus 4 multiplied by gamma. So, gamma x minus Vt, that is what is going to give me x1 prime, which turns out to be equal to 9 into 10 to the power 4 meters. It means according to an ambulance frame, this event occurred at a coordinate of 90 kilometers, 9 into 10 to the power 4 meters. Same to time transformation, T1 prime will be equal to 5 by 3. The time which is minus 1, it is gamma T prime minus Vx upon c square. So, this is T, which is minus 1 into 10 to the power minus 4, V is 0.8 c, x was 30 kilometers, 3 into 10 to the power 4 meters divided by c square. Substitute the value of c, you will find out that this time is minus 3 into 10 to the power minus 4 second. So, according to the observer in ambulance also, this event occurred before this particular person had reached the hospital. So, he was trying to drive towards the hospital and this particular event of distress sending signal being sent occurred at 3 into 10 to the power minus 4 seconds before this particular person in the ambulance was to reach the hospital, or a better word, the hospital to reach, because as far as he is concerned, he will feel that hospital is approaching towards him, for the hospital to reach him. So, we sort of again mix up the word, we say this person will reach hospital, because that is the way we visualize. If I am sitting in a car, I always visualize that, okay, I am going to reach to this particular destination. Okay. But actually what I visualize when I am sitting in the car that the hospital is coming to me, though we are somewhat casual in speaking and saying that, okay, I am going to reach the hospital. As far as event 2 is concerned, if you want to do a Lorentz transformation, you can do it, but it is not really necessary, because I know that when x is equal to 0, t is equal to 0, x prime has to be 0, t prime also has to be equal to 0. So, I just put E2 as x2 prime is equal to 0, t2 prime equal to 0. Of course, I must remind you that this prime side thing I have used for the A frame, for the H frame I have not used prime. Actually, we will be discussing later about the P frame, then I will be using double prime. So, just to make it clear. Now, let us look at event 3. Let us try to find out the coordinates of event number 3 in the ambulance frame. Strictly speaking, if one is smart and one has understood things quite well, to find out the coordinates of event number 3 in ambulance frame, one need not have to use Lorentz transformation. One can find it by a shorter route. But let us not do that at the moment. At the moment, let us just try to write Lorentz transformation and find out or work out the coordinates of event number 3 in ambulance frame. Later we will discuss which is a shorter way of solving this particular part of the problem, or just finding out the coordinates of E3 in ambulance frame. So let us look at this transparency for event number 3. I have to find out x3 prime and t3 prime. x3 prime, gamma x minus vt. Gamma we had already calculated, 5 by 3. For x3, that is the coordinate of the event in hospital frame of reference. It occurred at 19.2 into 10 power 4 meters. V is 0.8 c. Time was 8 into 10 power minus 4 second. So, it is gamma x minus Vt. It so happens, you just calculate this number, you will get it equal to 0. Let us look at the time T3 prime. T3 prime is equal to gamma 5 by 3, T which is 8 into 10 to the power minus 4 second, minus V which is 0.8 c, relative velocity between the frames, x 19.2 into 10 to the power 4 meters divided by c square. Gamma T minus V x divided by c square. If you calculate this number, this turns out to be 4.8 into 10 to the power minus 4 seconds. If you look at this particular value of E3, probably you would have realized that the shortcut that I was trying to mention. So if you are really sitting with respect to an observer in the ambulance, what you would feel that the car was approaching towards him. The car means the train compartment was approaching towards you. Like hospital was initially approaching, the hospital passed by, then you have the train compartment which is coming towards him, and then you catch them. That's the event number 3. So according to the observer in the ambulance, hospital was approaching him. The compartment, train compartment in which the sick person is sitting is also approaching towards him. So event number 3 occurred when he was sitting right there. And what is event number 3? Event number 3 is sick person and this particular person in ambulance meeting together. They are combining at the same point. So obviously, this particular event occurred exactly when he was sitting here. Similarly, event number 2. Event number 2 is the event when the light reached this particular person sitting on the hospital. And exactly at the same time, the ambulance was also passing by. So this event number 2 also coincided with this particular ambulance coordinate coinciding with the hospital coordinate. As you can see here also, if you go to the transparencies, x2 prime was equal to 0, x3 prime is equal to 0. Both the coordinates turn out to be same because both the events are occurring exactly at the same position. So for person sitting in the ambulance, the hospital reaching him occurred when he was at its origin. Obviously, the train reaching him will also occur when he was at its origin. So without working out Lorentz transformation, I could have immediately guessed the answer that x3 prime should be equal to 0. Now you would have realized that I could have calculated T3 prime also very easily, because just now we said that event number 2 occurred when x2 prime was equal to 0, event number 3 occurred when x3 prime was equal to 0. It means both the events occurred at the same position. If both the events occurred at the same position, then the time interval between these two events must be the proper time interval. Remember, it is in the A frame that both the events occurred at the same position. So time interval is proper in A's frame of reference, not in the hospital frame of reference. Because in hospital frame of reference, this particular catching is done at a distance quite far away, while the second event occurred at x is equal to 0. But in the ambulance frame, both these events are occurred exactly at the same position. Therefore, the time interval T2 and for event number 2 and event number 3, the time difference between these two is a proper time interval in ambulance frame of reference. Therefore, in hospital frame of reference, it must have been dilated. So, if I know the gamma values, knowing the time interval which I have already calculated, I have already calculated T1, T3, I can always, T2 and T3, I can always find out T2 minus T3 or T3 minus T2. And from that particular time interval, I can always find out T2 prime minus T3 prime or T3 prime minus T2 prime by just using the gamma. That's what I have written in the next transcript. It's just a picture showing whatever I have said, that this is somewhat different from the scene which was being looked for by a person in the hospital frame of reference. As far as the ambulance frame of reference is concerned, the first event occurred farthest off. So remember, it's just contrary to the hospital frame of reference. In hospital frame of reference, the chronology of the events were different. The first event occurred when he was closest to hospital. Second event occurred when he was farther away from the hospital. Third event occurred when he was still farther away from the hospital. But in the case of ambulance, it's different. In the case of ambulance, first event occurred, this particular train compartment was farthest off from there. When the second event occurred, that particular thing has come nearer to him. And the third event occurred at that time, it was just close to him. It was just at the same place where he was situated. So, the distance as the events keep on coming, keeps on decreasing in the frame of reference of the ambulance. Also, I would like to realize, I would like to mention that as far as the event number 2 is concerned, at that time, the origin of ambulance was coinciding with the origin of the hospital and not with the train. Train was still farther off. So, this is this picture which is showing this behavior, that at first event, this particular train was farther off him and it's supposed to be moving towards him. At the second event, when it occurred, it was still not at the origin, it was further off from him. And it was the third event when this particular train compartment has reached this particular ambulance. Again, I repeat, it's important that we should be clear about our frames of reference. We should be able to translate our thinking with respect to an observer who is sitting in that particular frame of reference. Then we are not likely to make an error. So, this is what the shortcut I was describing. We could have found out the coordinates of E3 without using transformation also. The x has to be 0 because it occurs at the origin of A frame. This is what we have just now described, that it has to occur at x is equal to 0. So, nothing surprising. I need not have worked out the Lorentz transformation equation. Second thing, to use time dilation. We can use time dilation for the time part. We realize that T3 prime minus T2 prime, it means the time difference between third event and second event as seen in the ambulance frame of reference being proper time interval between E2 and E3. It's actually in the ambulance frame that this particular time interval is proper. Therefore, in this particular frame of reference, which is the hospital frame of reference, T3 minus T2 must be gamma multiplied by this particular time interval, because this time interval is proper. So, T3 minus T2 must be a dilated time. So, if I calculate from this, substitute these particular values, I have just now calculated T3 minus T2 prime, which was 8 into 10 power minus 4. For T2 and T2 prime times were 0 anyway. So, this is equal to 0. This is also equal to 0. I substitute in this particular expression, I get T3 prime is equal to 4.8 into 10 power minus 4 second, which is exactly the same result which we had obtained here. So, we can very easily see that we get the same result without actually using Lorentz transformation. We can just use the time dilation formula, still get the same result. So, now I know all the events and I have filled the event table in the ambulance frame of reference. So, this transparency shows the event table in A frame. Event number 1 occurred at 9 into 10 power 4 meters and at a time of minus 3 into 10 power minus 4 second. Event 2 occurred at x is equal to 0, t is equal to 0. Event number 3 occurred at x is equal to 0 and at time 4.8 into 10 to the power minus 4 second. So, my event table is filled both in H frame and A frame. Now, let us look back at the question, see that whether we have answered all the questions, if there is something still remaining. Are all the questions answered? This is the first question which we had asked. What are the positions and times of the person sending the signal in H and A frame? It means basically when event number 1 occurred. Event number 1 occurred, I have already known the coordinates. I know the value of x, I know the value of time, both in H frame, both in A frame. Okay, I have to just pick up those values and plug it here. That's the answer. Second part, find the position of the person in the H frame at t is equal to 0 and in A frame at t prime equal to 0. See, at H frame at time t is equal to 0, I had calculated the intermediate position. Remember, we go back to this picture here. I had already calculated at time t is equal to 0, this distance is 48 kilometers. See, originally it was 30 kilometers. During the time light took to come to here, this has moved further away by 18 kilometers. So, this distance is 48 kilometers. So, this I have already calculated as an intermediate step, though it was not really related to an event, but we had already calculated. So, this distance is 48 kilometers. But what is the position of the person in A frame at t prime is equal to 0? I have not calculated yet. Okay, because this particular event, whatever we are talking, is occurring at different time and different values of x. So, this need not be correct. I have to still calculate this particular value. Third thing, find the time in H frame and A frames when the car reaches the person. When car reaches the person or the ambulance reaches the person, this car means ambulance. When this ambulance reaches the person, obviously this is time E3, this is the event E3. So, whatever is the value of x that we have calculated both in H frame and A frame. So, we have to just pick up those numbers, plug it here. Event number 3 tells me the solution of the last part of the problem. We have to still find out what is the position of the person at t prime is equal to 0. Let us go back here. According to A, that is an ambulance person, the event number 1 occurred when the person was at 90 kilometers away at time t prime is equal to minus 3 into 10 to the power minus 4 seconds. Remember, these were the coordinates of event number 1 in ambulance frame. So, it means the distance of that particular person who had sent the light signal was 90 kilometers, but the time in the watch of that particular observer sitting in the ambulance was minus 3 into 10 to the power minus 4 seconds. The problem is simple. I am looking only at the A frame. Question is that if there is a particular train which is at a distance of 90 kilometers away from me at a time minus 3 into 10 to the power minus 4 seconds, where it would be at time t prime equal to 0. I can find out if I know what is the speed of that particular train relative to me. So, I have to do a velocity transformation. If I do a velocity transformation, I can find out what is the speed of that particular train which is coming towards me. Then I can find out how much distance it would have traveled in time 3 into 10 to the power minus 4 seconds. Subtract that time, that distance, from 90 kilometers, I will find out where this particular person would be situated at time t prime equal to 0. So, during this time, as I have said, the person was traveling with a relative speed of ux prime. Let us calculate ux prime. Apply a velocity transformation formula. I have to go from the frame of hospital to the frame of ambulance. Relative speed v is 0.8 c. ux, this is the speed of train which I want to transform. I want to find out what is the speed of train in ambulance frame of reference. So, ux is the speed of train as seen in the hospital frame of reference, ux. So, this is ux 0.6 c minus v, which is 0.8 c, 1 minus ux into v divided by c square. So, there was a c here, there was a c here, that cancels with that c square. So, you get this value of ux prime, which is minus 0.2 c divided by 0.52. Obviously, there is a negative sign here, because as far as the observer in ambulance is concerned, the train is approaching to him, it is not going away. So, direction is minus x, it is towards minus x direction, that is why there is a negative sign. Now, the distance travelled by the person in A frame, as we have just now discussed, during this particular time, until the time watch shows t prime is equal to 0 in his watch, will be this particular speed with which this train is moving or coming towards him, multiplied by the time that I am talking, which is 3 into 10 power minus 4 second, which comes up approximately equal to 3.46 into 10 to the power 4 meter. So, this is the time, this is the distance that the compartment would have moved in ambulance frame of reference towards him. The original distance at time 3 is equal to 10 to the power minus 4 seconds was 90 kilometers. I have to subtract this distance from 90 kilometers to find out what will be the coordinate or what will be the position of the person in the frame of reference of the ambulance at t prime equal to 0. That is what I have done in the next transparency. The distance of the person in A frame at t prime is equal to 0 was the original distance 9 into 10 to the power 4 meters minus the distance that has been travelling, that this train has travelled in the frame of reference of A in the time 3 into 10 to the power minus 4 seconds. I get this distance approximately equal to 5.54 into 10 to the power 4 meters. So, this is the situation as far as ambulance frame is concerned. At the first event, the distance of this particular train was 90 kilometers. At the time of the second event, t prime equal to 0, this distance was 55.4 kilometers. And at the third event, this particular distance was 0. So, I have calculated all the distances. Sometimes it becomes easy when we picturize the thing. Remember, if I would just like to make 2 points. If you would have just transformed the first part, I will not get the same result as 5.4 kilometers, because that particular times are very different. So, that is one thing. The second part is, the second point that I wanted to emphasize is that when I calculated the time intervals or when I calculated the coordinates of all the events in hospital frame, I never used Lorentz transformation. Lorentz transformation was not required because all the information was given in the frame of reference. So, in principle, this problem could have been a standard classical mechanics problem, other than the fact that I have used that speed of light is same. Other than that, it does not require anything special. If all the information has been given in my own frame of reference, I do not require a transformation. Only when I go to different frame, transformation is needed. Now, though it has not been asked in this particular problem, let us spend a little bit of time in finding out things about P frame, the person's frame, the person who was sick. If I have to find out the absolute times, I will be somewhat in trouble. It is not really a trouble, but one can, if one wants one can do it. But the way the situation has been described, this person never matches either the origin of ambulance or the hospital at any time. And if I have to use Lorentz transformation directly, then I have to resynchronize the watches so that the times becomes equal to 0. For example, if I want to transform from hospital frame to this particular person's frame, then I have to make their time 0 when their origins were consonant. Or if I have to transform from P frame to the ambulance frame, again I have to make time t is equal to 0 when their origins coincided. This can become somewhat cumbersome. But if I use in the differential form, if I take the differences, then I need not have to bother, because that particular position of the origin does not matter if I am taking the differences, because that cancels out. So, if I have to ask or if I have to get some information in the person's frame of reference, the sick person's frame of reference, if it is given in the differential form, I need not resynchronize my watches, I can still get the answer. So, just one quick example about this thing. Suppose in the problem, we had also asked that find out the time in that the ambulance took to reach P in P's frame after sending the distress signal. So, look, imagine that you are the sick person sitting in the train and you have sent a signal to get some help. Now, you have said signal, let us say at a given time. How much time after I really got the help? It means the ambulance reached me. So, I asked for help. After how much time I got the help? So, if I have to ask this particular question, remember I am still talking of event number 1, that person, I am now imagine that I am the sick person. I am sending the signal. I send the signal. That was event number 1. Remember, same event. Event number 3, ambulance reached me. This is event number 3. Now, probably you would have realized that if I am the sick person, I am the person who is sending the signal. Obviously, I am always sitting at my origin. When I received the ambulance, again I received at the origin. These two events in the piece frame occurred at the same position. Therefore, time interval between event number 1 and 3. Number 1 and 3. This time difference is a proper time interval in piece frame. So, in the hospital frame and ambulance frame, this must be dilated. If I know this particular thing, it is very quick, I can find out the answer. I can choose, because anyway I have found out the time differences between E1 and E3, both in H frame and AA frame. I can use any of these things, use corresponding gamma values and find out time difference in piece frame. So, let us just take one quick thing. Let us assume the hospital frame. What I have written here, we realized that event E1 and E3 took place at the same value of xp. So, now I have put just 2p in piece frame. Hence, this time interval is dilated in H and A frames. For P frame, I have put a double prime. So, T3 minus T1, this is a proper time interval. T3 minus T1, this is the hospital frame of reference, must be equal to gamma pH. Let us be very careful that which gamma I am using, because now I am transforming in 3 different frames. Okay. It is between the person and the hospital, because T3 minus T1 is in the hospital frame of reference. So, I have to use gamma by using the relative velocity between P and H, which was anyway given to be equal to 0.6 c. The person was moving with a speed of 0.6 c in H frame, and we know that gamma pH we have done in many problems is 1.25. So, this T3 double prime minus T1 double prime, which is the time difference between event number 1 and event number 3 in the person's frame of reference, in the sick person's frame of reference, will be given by this time interval. If you calculate the time difference between event 1 and event 2, one was in -1, another was in 8. So, it becomes 9 to 10 power minus 4 divided by gamma, which is equal to 7.2 into 10 power minus 4 second. So, this is the proper time interval, and this is the time interval which will be measured in the sick person's frame of reference, which I am calling as P frame of reference. Just to check, if I multiply this by the gamma between A and P, person and the ambulance, then I must get back the time interval which I have calculated between E1 and E3 in the ambulance frame of reference, just to check if I have thought everything right. To use that particular gamma, I have to use the relative velocity between the person's frame and the ambulance frame of reference. So, I have just written, just to confirm, we can find the time interval in A frame using this proper time interval between E3 and E1 in P frame, person's frame. Exactly the same thing. This particular time interval was proper. I have to find out T3 prime minus T1 prime. I have to multiply by gamma PA. I had calculated the relative velocity as 0.2 divided by 0.52 c. C square cancels out. Gamma PA turns out to be equal to 13 divided by 12. Therefore, T3 prime minus T1 prime will be equal to this proper time interval multiplied by 13 divided by 12, which is equal to 7.8 into 10 power minus 4 second. If I go back to my event table, this is what you have to have seen. 4.8 and 3, this is minus, this time difference is actually 7.8 into 10 power minus 4 second. This is what I had expected. This matches with whatever we have evaluated using Lorentz transformation. In the end, I would just like to give my summary. Of course, in this particular summary, we have only solved one particular problem, which is a long problem involving 3 different frames of reference and 3 different events. So, we discussed one example involving multiple events. Thank you.